normal infiltration and pneumonia. And we have a data set of 3,000, about 3,500 images. We for sure have more than this, but then because of the filtering and the narrowing down, we ended up having this. I want you to think about the most underprivileged or vulnerable among us, the children under 5. A study conducted by the World Health Organization actually found out that about 16% of total deaths of children under 5, were as a result of pneumonia, and with a lot of that being around sub-Saharan Africa and South Asia. And this is actually a very serious problem, and it has a lot of implications. Number one, as you can see, it delays education, right? Kids who were deserved to be enrolled in school very early, are literally delayed or their lives cut off. But what is pneumonia? Well, pneumonia is a health infectious disease that attack the lungs, specifically the alveoli. So the alveoli are like millions of tiny sacs in the lungs, which actually helps us to breathe in oxygen.
Have a look. Beautiful. Yeah. The team is consistent of 1, 2, 3, 4, 5. Who are we? Just 3 things. Just 3 things. 1, you're skilled professionals. Everyone you see on the screen is really good at what they do. 2, we are ambitious developers. We all know how to code. And most importantly, number 3, critical thinkers. See, what you need to understand is we have this problem, and all 5 of us who said, how do we solve this problem? Very simple. We're going to build something. ITCA, ITCA VET, like Vets for Veterans. So we're ITCA Vets. So we decided to come with a very good solution, a model called MRCG, but for short, you can call it MneumoniaNet. Right?
And what does PneumoniaNet do? Well, PneumoniaNet is actually a very lightweight, built from scratch convolutional neural network model, and the size of it is actually 14 megabytes. And to put this in perspective, it is literally less than most of your favorite TikTok videos. And it is built on PyTorch framework, our target patient. So this is like a iterative issue without a challenge. And one of our challenge was basically the dataset. But what about the dataset?
The data handed over to us during the hackathon was expected to be a total of 9,000 plus images, but at the time we realized that it was 6,000 plus images. And then due to the scope of the hackathon, it's directed towards the pediatric, and then we chose 15 years and below. And due to that, we narrowed the quantity of images to 3,000 plus images. So one of the challenges we faced is that due to the low number of images, the model was memorizing the images and then the patterns. And as my partner earlier said, we used grayscale images.
Of course, Mr. Jordan. So, data imbalance. The nerds among us already understand what data imbalance is, right? But here's a problem. We were like, okay, data imbalance, how do we solve this? We got it, bingo. Weighted loss function. Okay, for those of you again who are in the field, you understand what I just said, weighted loss function. For those who aren't in the field, you're like, what's that? Well, to put into perspective, this is a conference, right? You have a lot of people, but imagine everyone's having their own individual conversations. What happens is, if someone whistles, you won't be able to pinpoint who the person is, right? So what we did, we said, okay, let's implement this weighted loss function such that, right, such that it's able to narrow down hyper-focus into the most underrepresented classes. You understand? So, in so doing, it is very, very easy for us to be able to get more accurate results. Check this out. Learning to see. This is the whole essence of computer vision. Okay, what does this mean? Okay, it's simple. You can see that it's essentially a heat map. You can see this region here that has, was really hard. The results. The results.
What about the results? Well, okay, I actually don't want to bore you with all of these graphs here. We have a lot of interpretation, plots, graphs, confusion matrices, thinking it was normal while it was pneumonia, right? And then we have saving, thinking it was infiltration while it was normal. And we have 32 correct cases, so as this guy mentioned here, this was the hardest part for us. And what we essentially do, there was only 12% of our data set that was basically consolidation or pneumonia. So what we do, we apply a weighted loss function because we are not supposed to completely replace doctors, right? The purpose of this is to assist, not literally replace doctors. And our role is to use this as an early screening and prioritizing system. And also, I mean, like, we usually just trust this, like every prediction should be verified by radiologists. And I think it's very important when making innovation to be honest about your transparency, to be honest about your ethics, to be honest about your limitations. Albert Einstein once said, "I am neither especially clever nor especially gifted. I am thousands of Einsteins." So this is our call to action, to ask more questions. And we believe AI can actually serve humanity. We believe AI can be used as a tool to propel humanity forward. Thank you.